Hello, welcome back to our top-level qualification TLQ SICAM A8000 substation system. My name is Jorge Diaz, and now I will present you how you can configure one of our smaller RTUs with the software SICAM Device Manager. So, first, let's see with a practical example so you can relate to what we are going to do. Let's assume we have a small substation with two bays, as you are seeing on the screen. We will have one small RTU, a SICAM A8000, for example, a CP8022, with an IP address, and then some of the signals of one bay will come to our system through conventional wiring. Let's assume that we have also some metering devices, maybe some SICAM P55 devices, which will gather the measurements of the bays and will send them to the RTU via Modbus RTU communication protocol. Let's also imagine that we have at least one CProtect device protecting one of the bays. This, of course, will have one own IP address and will be integrated through a network switch through the IC61850 communication protocol. The RTU will be, of course, connected to the same network. So the RTU will read information from this device. And now let's imagine that we have one control center with its own IP address, and we will send the information from the RTU to this control center through the IC104 communication protocol. One final thing that we will consider in this example, so you can see the whole picture, is that we will have a time reference for the whole system, a GPS receptor that will work as an NTP server with its own IP address. So it will be connected to the same switch, and we will get the time from there in the system. So first, let's define which is the hardware that we have in this configuration. We will have one CP8021 or 22 connected directly with the power supply, and from there we will have one module for the binary outputs, DO8212, one module for the binary inputs. Okay, so first you need to install SICAM Device Manager in your computer. So normally you can install SICAM Device Manager in a computer with a Windows 10 operating system. There are also some other operating systems that are supported. You can check this in the manual. You have also to provide a valid license to be installed in your computer to be able to operate with SICAM Device Manager. This license you can receive, you can order in a USB stick, or you can also order it to be delivered via online software delivery. The license is installed in the computer through the Automation License Manager, which is automatically installed when you install SICAM Device Manager. There are basically two types of licenses that you install in the computer. One is called the basic license. This allows you to configure any amount of RTUs that you want, all data points, all communication protocols. The only thing that is not included in the basic license is the configuration of CFC logics. There is no CFC editor there. If you need to configure also CFC logics, then you need the standard license. All the same functionality as in the basic license, but in addition, you have a CFC editor. Now, if you install SICAM Device Manager on your computer for the first time, and you don't have a license yet, the software will ask you, when you open it for the first time, to activate a demo license. This demo license allows you to do exactly the same, that it has the same functionality as the standard license. so including CFC configuration. The only limitation is this has a duration of 21 days. So for 3 weeks, you have the full functionality of Device Manager. You can test it, so you can be sure that it suits your needs, and then you can purchase the valid license and install it afterwards without any problem. Now, let's start working with the SICAM Device Manager software. You just open it by clicking on the icon in Windows as usual, and then SICAM Device Manager will be open. When SICAM Device Manager has been installed for the first time, there is no project in your computer. So it will open, giving you a welcome message and indicating you what step can you do next. It is telling you there is this menu, so-called hamburger button on the upper left corner, and with this you can select to create a project. So we select project, create. We must select a name for the project. So for example, we can call it TLQ. We can select a project folder, for example, C temp. So the project TLQ will be stored in the folder C temp. You can add a description header and a description detail if you want. It's not a must. You can leave it empty if you want. After you have done this, then the container for the project has been created. The software will tell you what can you do next. You have two options. You can create a new folder inside of your project or a new device. You can see in Device Manager that you are in the TLQ project. Here we need the home of the project. If we want to create a structure of folders here, we create a new folder through the button Create Folder here. We click here and we can select if we want to organize our signals, our RTUs, maybe according to voltage level. So you can select it like this, or maybe it will be according to a station name or a region, for example. It's up to you. You select the name, and then a folder has been created. Now, we have performed then a change in the project. We can see that here on top, this pencil symbol has turned red. This indicates that there are unsaved changes in the project. So if I close the project without saving, they will be gone. If I click on the symbol, it will turn to be dark blue again, indicating that the last changes have been safely stored. I can create now more folders here if I want to create like a structure, or I can navigate into a folder. By clicking on that, I know that I'm in the project TLQ folder 20 kV. I can proceed now to create even more folders if I want to structure it even more, or I can just proceed to create directly an RTU. You can create an RTU even without creating any folder. To create an RTU, I just use this button, Create Device. When I click on it, then I get this message window. Here I must define which is the name of the RTU. Maybe I will put CP. Could be any name that you want. You select the type of RTU. So in this case, could be a CP8000, a CP802122, or a CP8030, or a CP8050. Or you can also configure here signals for SICAM SEC. At the moment, we will select a CP8021. Then we have the engineering address. This is the IP address that will be used by Device Manager to try to reach this RTU when we are online with the RTU. By default, any new RTU or any RTU that has been set back to factory settings will have this IP address. So for the time being, we will just leave this address like that. We should also define a region number and component number. These are required for sure and mandatory if you are working with a device with redundancy, like in the CP8050. For the smaller devices, it's not a must, but we strongly recommend to assign a unique region and component number to each RTU. So in this case, I will say region 1, and component, this will be my first RTU, I can say 1. Now, we have here also common ASDU 1 and 2. These common ASDU are basically defined in the IC104 communication protocol. And we define this here for the RTU because IC104 is the mother language of the SICAM A8000 family. Every signal that we create in a SICAM A8000 RTU has an IC104 address. And the address that I'm defining here defines the common ASDU that will be assigned automatically to any new signal that I create for the RTU. That's it. If the connection with the control center will be done through 104, then I would also recommend to set here then the address of the common ASDU that will be assigned to the RTU for this control center. Let's say we could be in this case 1 and 0. And I can add a description if I want. This is not mandatory. I confirm, and then we have seen here a container for this RTU has been created. And again, I have my pencil symbol in red. I save. So now that I created the container for my RTU, I can now navigate to this container. I click on it, and then I can see that I am in the project TLQ in the RTU CP8022, and I can see the so-called dashboards or boxes. Here I can navigate to the different configuration parts of the RTU. The first thing that we must do now is define the hardware. So for that we go here to the dashboard, which is called Hardware and Protocols. Now we get, for the smaller RTUs, this menu where we must select which is the central processing of this RTU. We selected, when we created it, this would be a CP82X. So now we can select if this will be a CP8021 or a CP8022. The system will also offer me the versions of firmware that have been installed or are available in SICAM Device Manager for the CPU. In this case, for this Device Manager that I have installed here, I have two different versions available. For the CP8022, the revision 14.12 or 16.10. So I will just select one of them, the last one. And then automatically the system is equipped with also a firmware for SICAM Web. SICAM Web is the application that allows me to connect online with the RTU and to load parameters and perform diagnostics. And then I can select also individually, I can change the version of SICAM Web. Of course, we recommend to use always the last available one. Now we can also define already the hardware of the RTU, the inputs and outputs. So we have here, for the group of 8 modules that we will connect, we must select if the modules correspond to a SICAM, to our standard modules of the RTU. We select this USE081 and we select the latest available version, 9.10. Now I can see that the first slot is available now. For the module 0, I will select the binary output module, DO82, 10, 11, 12, 13. For all I use the same, all have 16 binary inputs. Then the next module is available. For this, here I will put, the first one was binary output, my mistake. The next one will be binary inputs, DI. So the first one, DO8212, next DI81, 10, 11, 12, 13. If I had additional modules, analog inputs and outputs, then I would put them here. I can also select if I want to have communication protocols here. I can select, for example, for Modbus master, because we saw in the configuration that we will have some IDs connected. So Modbus master. And protocol 1, we saw that we will also integrate one device via 62050. So I select here ET85 62050. And we also saw that we want to send information to a control center. So I will select the protocol to be ET84 IC104. With this, we have fully defined the hardware of the RTU. Now I can just save. Now I will switch to home, and I can proceed to perform some basic definitions in our RTU under RTU settings. So in RTU settings, again, you see that we are on the project TLQ, the RTU CP8022, under RTU settings. You can see that on the left there is a tree where we can see the structure of the RTU as we have defined it with the central processing. Here we have also the communication protocols. Here we have some area to work. Let's see that we have some parameters here. And you can see here on top this I symbol. If you browse on it, you see a hint about what this button does. It says show all parameters. If I click on it, then you can see that here are more parameters available now. If you click again, the circle around the eyes disappears and I have less parameters. So this is the switching between standard parameters and all parameters. The message here is if you are looking for a specific parameter and you cannot find it, odds are that this menu has not been activated. So you can always try to use it for that. Now, what else do we have here in the configuration? We have here basically AU common settings. If you go to AU common settings, you will see again the region and component number that we defined when we created the RTU. You can always change it. You are not forced to keep the ones that you defined at the beginning. So this gives you really freedom for that. You can define here customer, plant name. You can define the name of the device. Further information, important. You can select here common address of ASDU. The same that you define at the beginning. You can change it here. So full freedom. Next important thing, time management. So on the time management, when you go to all parameters, you can define if the RTU will be time synchronized or not. By default, the setting is remote synchronization or NTP. Remote synchronization means through a telegram from a control center, and NTP through a GPS. In this case, we are going to use NTP. If you don't want the RTU to be synchronized, so you will have to set the time by hand, then you select none, free running. In this case, the RTU doesn't expect to be synchronized and no time synchronization error will be issued by the RTU. If you select remote, then it will expect to be synchronized. If it is not synchronized, you will get a warning indicating that it has not been synchronized. You will see some extra parameters in the RTU, in the configuration, always. And sometimes you just don't know what they mean. For example, here, monitoring time for synchronization event. So here I just want to give you a hint in Device Manager. So most time you will see on the right orange ribbon. with this button. If you select one parameter and you click on it, then odds are that there is already a built-in help text there that will indicate you the meaning of the parameter. So this is always useful if you don't know what something means. Maybe there is already the information there. You can always try to check it. If you want to hide it again, just click here. So you can select here in daylight saving time if you are, or the RTU is going to work in a country where there are switching between summer and winter time, then you must set it here. If you don't want, if you live in a country where there is no summer winter time switching, then you put it to no. You can define here the time zone where the RTU is going to work. These are the first settings that you need to define here. Next, network settings, quite important. IP address. So as I mentioned, when you receive an RTU in factory settings, it will have this IP address, 172.16.03. So this is the default address that is also offered when you create a new RTU. You define, of course, subnet mask. You can define a gateway if the connection will not be direct, but through a router. And you will see that by default here, the mode of Ethernet ports has been set to one IP address. This means the two LAN ports will work with the same IP address. Each port of the CP8050, of the CP8021 in this, or 22, has its own MAC address. If you select this mode, then only the MAC address of the first LAN port will be used. They will work like in a team mode. If you want to have each port with a specific IP address, then you select here this mode, two IP addresses, independent ports. Then you have here the possibility to set one port for the port X1 with its own mask and another IP address for the port X4 with its own mask. You can select that one will work with GPRS while the other will work with LAN settings. And now you see also here, if you expand here, you will see that there is an additional setting that was not available when we had one IP address. When two IP addresses, you can select in interface mapping for each protocol element which LAN port will be used. Also, for the services for NTP time synchronization client, you can select through which port will we be clients, or if the RTU will send monitoring diagnostic information or asset management information via SNMP, through which port will it be sent. Also for the radius client management, we will go to this in a second, through which ports, etc. For simplicity reasons, during this presentation, I will just work with one IP address, but you already know where you can activate independent addresses for your RTU. So other important settings in the RTU, I will expand this a little bit, and we can see here NTP, time synchronization client. So in this example that we want to configure, we want to synchronize the time of the RTU through NTP. So I select here time synchronization client through NTP, yes. And then I'm offered to select up to 4 NTP servers to use as source. So I will just write here 100, the address of the GPS clock that will be working as an NTP server. And that's it. That's all I need to do. Now, if I want the RTU to work as a backup NTP server in case the source failed. So to be used, for example, to synchronize the protect devices that are connected in the network in case the GPS is faulty. Then I can activate it also here, NTP time synchronization server. I just say yes, and that's it. Here we have also a very interesting setting for the small RTUs, the HTTP web server. So all the configuration and the diagnostic of the RTU is done through the very secure protocol HTTPS. But there are some functionalities for diagnostic or testing of certain protocols available under HTTP server. I recommend it for commissioning of protocols such as Modbus RTU to activate this feature, or 6150 is also available. In this case, I can monitor some specific parameters of online of the communication protocol via this HTTP server. And in order to do that, I need to activate this feature here. At the end, if the system is already working and if the security requirements of the company where the RTU is installed require that there is no HTTP connection enabled, then you can disable it, no problem. Here also we can activate SNMP parameters. If we want to monitor the RTU via SNMP, I can activate it here. Role-based access control, quite important. All the access to the RTU is based on role access-based control. And by default, it is set radius authentication no, which means it will be only local user administration in the RTU. On the RTU itself, you will have to define your users and the passwords. If you set this radius authentication to yes, then you can use an external system for the user management. For example, like Windows Active Directory. You just need to select how this system will communicate with the RTU to define the users, to enable the users. And the protocol allowed in the available in the small RTUs, CP8000, 8021, and 8022, is radius. For the Linux-based RTUs, you have the possibility to use radius or LDAP. In this case, you just activate it and you select the address of the radius server, which could also be redundant. Fallback means in case this server is not accessible, then you can always have local user administration as a backup, so you never lose access to the RTU. For simplicity, in this example, we will set this to no, but you already know where the settings are. Now, password policy. You don't define users and passwords in SICAM Device Manager. You only define rules. This is for local administration. You can define, for example, a password policy where you define a maximum number of attempts, failed attempts, within a specific consecutive time. If this happens, the corresponding user will be blocked from access for a specific blocking time. This you can define here. You can also define, expanding here, the password settings. So you can define a minimum amount of capital letters, of small letters, of special characters, minimum number of digits, and a minimum password length. You define only these rules. Users and passwords are not defined in Device Manager. Quite important to keep in mind. We will see this also in another module of our TLQ. Basically, this is the most important parts of the basic configuration of the RTU. Now we will proceed with the configuration of the binary inputs and outputs in the RTU in our next video.